Welcome back, guys. Today we're going to talk a little bit about the Batrium software. In more detail, we are going to take a look at the balancing features in the Batrium. Batrium software have two general types when it comes to balancing. The first type is the top balancing that is done when you reach or go above a certain set voltage. The second balancing is something that you can set between three different types, and that's the main topic today. In the Batrium software, to be able to set the balancing feature, you go to the menu, you press hardware, and you go to the cell-mon. The first balancing that is done is so-called bypass balancing, and that's when you're reaching a voltage of any of the cells above the bypass volt. In my case, I have set the bypass volt to 4.1 volt, and as soon as the battery goes above that, the Batrium system will instantly start to decrease the voltage by bypassing the current through the long mons or the mons that you are running. Bypass current as such is set up down below here, and you have a bypass current currently set to 0.96 amp, and the maximum temperature I have set here is 75 degrees Celsius. The values used here are pretty standard. And as you can see, I'm using the custom cell-mon type. And the reason for that is because I wanted to lower the bypass current just slightly. By lowering the bypass current in my case, and the long mon doesn't get as hot as it generally does. In the Batrium software you have a couple of more bypass modes enabled. If you go to edit, you are able to actually go into the bypass extra mode. Normally it's set to none, and then you have the idle shunt, you have the cell volt, and you have the auto level. What I'm going to go through today is the auto level functionality. To set the values for the auto level functionality, you go into the more. In the more window you have four categories where you can set different type of values to be able to do the auto level functionality. So let's go through them a little bit quick. You have something that is called a time interval. The bypass extra time is the amount of seconds it bypasses or tries to level the cell at each time before it actually recalculates the values it has. The cell volt stable time is the amount of time that the cell itself needs to be stable in terms of voltage before it actually goes into the bypass mode. And this is to prevent the system to not start to bypassing when you're having heavy loads going up and down. In most situations you do not want to actually do the balancing when, for instance, you are discharging the battery. Because discharging the battery you want all the energy you have and can utilize. Normally the value for discharge should be somewhere around 2 amps. On the other hand, the charge current limit should be changed, at least if you ask me. On a rather busy system you may not even go into or between -2 amps to +2 amps that are the default values. And that's because you have loads going up and down all the time. Next part is the cell volt comparison, and this is also very important. For instance, the different gap is the gap between the maximum and the minimum cell. If that is above, in my case 0.03 volt, that sets the state of the bypass to be able to go to the next level. Everything on this screen or in this window here need to be true in a sense for the bypass to actually start. Bypass banding, on the other hand, is the group that should be bypassed or balanced. For instance, if you take a look at this image here, you will see that we have cells reaching from one level of voltage to another level of voltage. So what the bypass banding does, it starts with the top cells that are within, in my case, 0.05 volt. For instance, in this image here, you see that I have marked the ones that will be included. Cutout limit, on the other hand, is between what ranges of voltages or state of charge will you do the balancing. In my case, the lowest cell cannot be below 3.8 volt. And the state of charge need to be above 70%. Basically, in my case that I have set up here, everything needs to be true. The bypass extra time, that's just the time you set for how long it should be running for balancing. The cell volt stable time means that the voltage needs to be stable for 2 minutes before it starts. The shunt current needs to be somewhere between -2 amp and +30 amp. Different gap, that means that the difference between the max and minimum voltage of the cells need to be more than 0.03 volt. The bypass banding is just a setting that defines what cells that should be balanced, and in this case all the top cells that are within 0.05 volt. The voltage of the minimum or the lowest cell cannot be below 3.8 volt, and the state of charge need to be above 70%. So let's go back and check all the parameters to see if we can get this to start. First of all, the stable time is something you can see here. If you can see that the repeat value is 6700, that means it has been stable for enough time. You can also go to menu, telemetry, and you go to cell info, and you can check the number that says repeat C. That's the number of times that the updates came from the long months that have had the same values. If it says 250, we have a very stable value currently. And as you can see, everything is met there. So let's go back to hardware and Cellmon and press more. So basically, what we have met is the value of the cell volt stable time. If we check the shunt, we can see that we currently are discharging with minus 1.2 to 3 amp. And the state of charge is only 68%. So let's go back again to Cellmon and more. The current that we are discharging at is meeting the requirement as well, but the state of charge is not. So let's change the state of charge so we can get this running. Let's change that one to 60% instead. So now that is correct. Okay, don't forget to save. So basically we need to check a couple of more things. So go back to the chart, and we can currently see that the lowest voltage of the system is 3.77 volt and the highest is 3.86. Menu, hardware, Cellmon, edit, and we can see here that the lowest need to be higher than 3.8 volt. And so let's change that to 3.7 volt to get this going. And you press OK, and you press save. So what you see now is that this icon came up. This icon means idle bypass adjustment is running. That's the auto level function that we just enabled. So let's go back to the dashboard. So basically what will happen now is that the cells that are in a banding of 0.05 volt should start to balance. And we have the top one first, that is 385 volt. Let's see what more we have, 383 volt. So that one should theoretically start to balance as well. And we might have that one and that one. No, those are actually below because this one is 3.86. But this one started as I said as well. So basically the banding means that it takes the top row cells. So this, guys, is how the balancing is working. It's a nice feature, but you need to set it up correctly for it to do what you want. Recommended values of state of charge. This depends a little bit. I would say you need to be above 70% for this to actually be properly. So in this pack I'm actually running 70%. And the voltage, 3.85 perhaps. I will leave the different gap and bypass bending because I think those values are good, and the shunt threshold as well. And we save it. By saving this, the bypass turns off again. So guys, I really hope you enjoyed this video. This was a quick rundown of the bypass feature that is called auto leveling in Batrium software. If you haven't bought your own Batrium software and you like what you see, take a look at the links down below. I will have links to Batrium webpage. I also have linked to other stuff that I'm using in my system. And if you're interested on the Grafana Raspberry Pi ISO that I'm working on, there is soon coming out a new version, but currently you can check out the old one if you want. And once again guys, thank you for watching, and we'll see you next time. Bye.